Let's build some solar cells. What's up everybody, it's Tahir and welcome back to the channel. Today we're diving headfirst into the world of perovskite solar cells. Now you might be thinking, Pero what, don't worry, I got you covered. These bad boys are like the rock stars of the solar industry. They're crazy efficient, relatively cheap to make, and have the potential to revolutionize how we power our world. We're talking about ditching those bulky, expensive traditional solar panels and replacing them with something lighter, more flexible, and way more awesome. Imagine slapping a perovskite solar cell on your backpack to charge your phone, or even integrating them into your clothes. Sounds pretty sci-fi, right? Well, it's closer to reality than you might think. And the best part is we're going to break down the science behind how these things are made. Today, we'll explore the top 5 methods used to create perovskite solar cells, from simple lab techniques to large-scale manufacturing processes. So, buckle up, get ready to learn, and let's build some solar cells. Alright, let's kick things off with the most common and cost-effective method for making perovskite solar cells, especially for all you DIY scientists out there, the solution processed method. Think of this like making Kool-Aid, but instead of sugary drinks, we're making cutting-edge solar technology. First, we need our ingredients, which in this case are perovskite materials in a liquid solution. We mix them up according to a precise recipe, kind of like following a baking recipe, but with way cooler results. Now, there are a couple of ways we can turn this solar Kool-Aid into a working solar cell. One way is called one-step solution deposition. We basically take our solution and spread it onto a substrate, kind of like spreading frosting on a cake. We let it dry and boom, we've got ourselves a perovskite film. It's surprisingly simple, but it works like a charm. Another method is called two-step sequential deposition. This one's a bit more involved, like making a layered cake. We first deposit one part of the perovskite solution, let it dry, and then deposit the second part on top. This gives us even better control over the film's structure and properties. And then we have the vapor-assisted solution process, or VASP for short. This one's for the true science nerds out there. We use a combination of solutions and vapors to create the perovskite film, resulting in smoother, more uniform layers. Now you might be thinking, Mark, this all sounds way too easy. And you know what, you're right. There are definitely some challenges with the solution processed method. Controlling the crystal growth, getting a uniform film, and preventing defects are all things that can make or break your solar cell. But hey, that's what makes it fun, right? Overcoming these challenges is all part of the scientific process. And trust me, the results are worth it. Alright, moving on to our next contender, vapor deposition methods. Now, this technique is like the professional chef's version of making perovskite solar cells. It requires more specialized equipment and a bit more finesse, but the results are top-notch. We're talking about super precise control over the film thickness and uniformity, which is crucial for high-efficiency solar cells. One popular method is called dual-source thermal evaporation. Imagine 2 ovens, each containing a different perovskite ingredient. We heat them up until the ingredients evaporate and then carefully control the vapors to deposit onto a substrate, layer by layer. It's like building a solar cell atom by atom. Then we have chemical vapor deposition, or CVD. This one's a bit more hardcore. We introduce reactive gases containing perovskite elements into a chamber with a heated substrate. The gases react and deposit onto the substrate, forming a thin film. It's a bit more complex, but it allows for excellent control over the film's composition and properties. Now, the beauty of vapor deposition methods is that they produce incredibly uniform and high-quality films, which translates to more efficient solar cells. But of course, there's a trade-off. These methods require specialized equipment and can be more expensive than solution processing. But hey, sometimes you got to spend a little extra to get the best results, right? Chapter 3, blade coating, also known as Dr. Blading, spreading solar cells like butter. Okay, let's talk about blade coating, also known as Dr. Blading. This method is all about simplicity and scalability. Imagine spreading batter on a pan to make a crepe, and that's basically what we're doing here. But instead of batter, we're using a perovskite solution. And instead of a pan, we're using a heated substrate. We take our trusty blade, carefully spread the solution across the substrate, and let the magic happen. As the substrate moves, the blade shears off excess solution. leaving behind a thin, uniform film of perovskite. The heat helps to dry and crystallize the film, creating our solar cell. What's great about blade coating is that it's a continuous process. We can coat large areas quickly and efficiently, which makes it ideal for mass production. Plus, it's relatively simple and doesn't require crazy expensive equipment. But of course, there are a few caveats. Controlling the film thickness and uniformity can be a bit tricky, especially at high speeds. And sometimes the blade can leave behind streaks or imperfections, which can affect the solar cell's performance. But overall, it's a solid method for making large quantities of perovskite solar cells. Chapter 4. Inkjet printing solar cells like your photos. Alright, get ready for this one because it's about to get really cool. We're talking about inkjet printing solar cells. That's right, the same technology you use to print your vacation photos can be used to make cutting-edge solar technology. How awesome is that? Instead of ink, we fill the inkjet printer cartridges with perovskite solution. The printer then deposits tiny droplets of the solution onto a substrate in a precise pattern. We can even print different layers on top of each other, creating complex structures and designs. Think of it like using a super precise paintbrush to paint solar cells onto any surface you can imagine. This method is incredibly versatile and allows for some really cool applications. Imagine printing solar cells directly onto clothing, backpacks, or even buildings. Of course, inkjet printing has its limitations. It can be a bit slow for mass production, and the resolution isn't quite as high as some other methods, but for creating custom designs and small-scale applications, it's an incredibly powerful tool. Chapter 5. Slot die coating, the solar cell assembly line. And last but not least, we have slot die coating, the champion of large-scale perovskite solar cell production. This method is all about speed and efficiency. Imagine a high-speed conveyor belt with perovskite solution flowing continuously from a narrow slot onto a moving substrate. That's basically slot die coating in a nutshell. The solution spreads out evenly, creating a thin film that dries and crystallizes as it moves along the conveyor belt. It's like a well-oiled machine, churning out perovskite solar cells with incredible precision and speed. This method is perfect for mass production, as it can produce large quantities of high-quality solar cells at a relatively low cost. It's also highly controllable, allowing for precise tuning of the film thickness and uniformity. Of course, like any other method, slot die coating has its challenges. It requires specialized equipment and precise control over the solution flow rate and substrate temperature. But when done right, it's an incredibly efficient and cost-effective way to manufacture perovskite solar cells on a large scale. Chapter 6. Perovskite power. The future of solar is here, and there you have it. The top 5 methods for fabricating perovskite solar cells. From DIY solution processing to high-tech vapor deposition and everything in between, we've covered the most exciting techniques for creating these game-changing solar cells. Each method has its own unique advantages and challenges, making them suitable for different applications and scales. Whether we're talking about small-scale research projects, custom designs, or large-scale manufacturing, there's a perovskite fabrication method out there that's up for the task. So, what are you waiting for? Dive into the world of perovskite solar cells and explore the endless possibilities of this revolutionary technology. The future of solar is here, and it's looking brighter than ever. Don't forget to like and subscribe for more awesome science videos, and I'll see you in the next one.